Hello everyone. In this presentation we are going to talk about the Treasury Coin. It's a prototype implementation of the perspective treasury system that was presented in the paper written in collaboration between IOHK and Lancaster University. So in the presentation we are going to discuss the needness of the treasury in general and then talk about the prototype. I will describe the main features and also will show a short demo of a working testnet. So let's begin. First of all, let's talk about the motivation of developing a treasury system. Modern cryptocurrencies are complex systems that require continuous maintenance. Even though it's usually proclaimed that such systems are completely decentralized, all existing cryptocurrencies have core team of members that at least controls the development effort. It becomes crucial how the core team is funded. If it is paid by some standalone investor, most likely they will follow his wishes that are not necessarily beneficial for a cryptocurrency general well-being. If we take a look at almost all modern cryptocurrencies, we can note that their funding and correspondingly the decision-making process is centralized. The sources of the funds can be different, but the accumulated tokens are usually controlled by one person or a small group. Treasury system aims to solve this problem by providing means for establishing collaborative consensus among all cryptocurrency stakeholders about stable finance in a system. So the basic idea is to provide a more decentralized way for decision-making process and give a community possibility to participate in it directly. With this in mind, a universal treasury model has been developed that can be adopted by any blockchain system. The developed treasury system is presented in the paper A Treasury System for Cryptocurrencies, Enabling Better Collaborative Intelligence. It's a joint work of IOHK and Lancaster University. By the way, there is a very good presentation of the treasury made by Professor Bingsheng Zhang, and it's available at YouTube. If you want to know more details about the system, you can also check this whiteboard session. Moreover, to support and verify the theoretical results, we implemented the proposed treasury system over an existing blockchain platform. The prototype is named Treasury Coin. But before I will switch to the prototype description, let's talk a bit about the treasury model itself. The main idea is to provide the tools for the cryptocurrency community to control the funding of the different projects. The basic scheme is very simple. Anyone can submit a proposal that requests money for some project, then the stakeholders vote on this proposal, and if it receives enough support, it will be funded from the treasury store. The treasury store in most cases will comprise from the newly minted coins, but other sources are also possible. This kind of funding was first implemented in Dash, but we went further and developed the advanced version of such scheme with many additional features. Moreover, we provided full mathematical description of the generalized model and proved within the universal composability framework that the scheme is resistant against different types of adversaries. As I said, the decisions on proposals are made by stakeholders, but not all stakeholders can participate in voting. Only those can who locked some amount of tokens for some period of time. We call such lock as deposit, and it is a part of the incentive mechanism to behave honestly. The voting power is proportional to the size of the deposit. Except voters, there are also experts and community members roles in our treasury. Experts is a special type of voter to whom a voting power can be delegated from the regular voters. And committee member is a special technical role needed for managing voting procedure. The Treasury funding itself is an iterative process. Each Treasury epoch is expected to be approximately 1 month. This period is divided into separate stages. The main stages are registration, which includes voters, experts, and committee members' registration. The voting stage, where voters and experts issue their ballots, and the tally stage, where the result is obtained and payments are processed. Of course, these main stages include a lot of sub-stages needed for maintaining the complex cryptographic protocols. The general scheme that I described is actually fairly simple, but it is backed by advanced cryptographic protocols that allows to achieve several very important properties. The most important are secrecy, full verifiability, and fairness. Secrecy is a property that allows to keep all personal choices of voters and experts in secret. It's achieved through ballots encryption. There is a special type of cipher is used that provides so-called homomorphic property. It means that it is possible to do mathematical operations with the encrypted messages. So in our case, it becomes possible first to sum up all of the voids in encrypted form and then decrypt only the final result. In this case, personal ballots with choices are never disclosed. Full verifiability means that everyone can verify the correctness of the final result. But actually everything can be verified, not only the final result, but also, for instance, the correctness of the voting ballot or the correctness of the distributed key shares, etc. It's done because all interactions go through a public blockchain and because of active usage of the zero-knowledge proofs, which allows to validate encrypted messages. So it becomes impossible to manipulate the final voting result, even if more than half of the committee members are corrupted. And fairness is a property when no one has an advantage of knowing partial results of voting. It holds because a voting result is decrypted only when the voting is finished. As I said, a lot of advanced cryptography were employed. So now I will briefly describe what cryptographic protocols were used to give you some feeling of the complexity of the underlying protocols. First of all, need to mention that a special committee was introduced which manages needed cryptographic operations. Committee members should be registered as well as voters or experts, and they also need to do a deposit which can be burned in case of malicious behavior. The committee plays a very important role. First of all, it runs the 6-round distributed key generation protocol and produce so-called shared public key, which will be used later by voters to encrypt their ballots. Such complex protocol is needed to guarantee that no one can manipulate the shared key and to allow recovery in case of faulty members. Also, at the final stage, committee runs joint decryption protocol that has 4 rounds. Committee members use their personal shares to decrypt the voting result. In case of faulty committee members, their personal secret keys will be reconstructed by others. So even if some of them fail to provide their decryption shares, the final result can be decrypted anyway. The third important protocol that is run by the committee is a randomness generation for the next epoch. Basically, each committee member does a commitment of his randomness, and later on they are decrypted and combined to produce a single random string, which will be used to select next committee. Worth to mention that even though regular full nodes don't participate in these protocols directly, they verify all transactions during the protocol execution, and they are also able to verify that a tally is calculated correctly. To provide some benchmarks and to test the proposed treasury system in real conditions, we implemented a prototype in Scala. Actually, it's a fully functional cryptocurrency prototype. As a base, we took Scorex framework, which provides basic blockchain functionality. It is a flexible modular framework designed particularly for fast prototyping. It has quite rich functionality that includes, for instance, full implementation of the Twins Coin consensus protocol that we actually took as our underlying blockchain system. Twins Coin is a hybrid consensus protocol where part of the blocks is issued with proof of work and another part with proof of stake models. Scorex also provides simple transactions model where we can send tokens from one account to another, and actually it's completely enough for our goals. So we took the Twins Coin implementation and extended it with the proposed treasury system. To do this, it was required to modify the existing transaction structure and block validation rules. We also introduced new structures and modules for keeping treasury state, managing transactions forging, wallet functionality, and many other stuff. All cryptography related to the voting procedure were implemented in a separate library to simplify code maintenance and to allow potential reusing it not only in the blockchain systems but also as a standalone voting system. Regarding the functionality implemented in the prototype, we actually implemented everything that was described in the paper. I will briefly go through the functionalities presented in the prototype. First of all, we have a proposal submission. Currently it's very simple. Only name and requested sum of money should be provided. We have waiters, experts, and committee members registration with deposits. Security deposits were implemented through the Lockheed UTXO records. We have random selection of the committee among all registered committee members. We implemented full-fledged 6-round distributed key generation protocol with all their knowledge proofs of correctness of the messages and such like stuff. Of course, we have ballots casting with zero knowledge of ballot correctness. We have 4 rounds protocol for joint decryption of the tally, including recovery of the faulty members. Also, there is a randomness generation for the next epoch, and we have a payment transaction with reverse distribution and penalties for some inappropriate actions like absence during the decryption phase, etc. Most of the operations don't require direct user involvement and were automated, except the proposal submission and ballot casting. A user only needs to configure the node properly and start it. All complex actions like registration, randomness extraction, joint decryption, and all other are completely automated. We did some testing of our Treasury Coin prototype. During the test, we were able to launch a local testnet with 12 full nodes that worked successfully several days. There was 9 waiters, 3 experts, and also all nodes were registered as the committee members. But the committee itself was set to be 10 members, so there was an election of 10 members out of 12 each epoch. Different number of proposals were submitted each epoch. The size of the epoch was 780 blocks with 10 seconds block generation time. During the tests, many abnormal situations were simulated, for instance, a malicious behavior of the committee members, absence of the waiters and experts, refusal to participate in the decryption stage, etc. With a correctly working majority of the committee members, the voting results were always successfully obtained and rewards were correctly distributed. Also, I recorded a short demo where I show how to launch a testnet, submit a proposal, and all other stuff. Now I'm going to show it. Actually, the epoch lasts quite long time, so I just recorded the most interesting parts and cut out the period when I just waiting for a particular epoch stage. So now I will show this demo. Hello everyone, now I will demonstrate Treasury Coin, a prototype implementation of the treasury system that is described in the paper named A Treasury System for Cryptocurrencies, Enabling Better Collaborative Intelligence. The prototype is implemented on top of the Scorex framework that provides basic blockchain functionality. It's publicly available on GitHub in IOHK repository. The link you can see on the screen. The purpose of the prototype is to provide a reference implementation of the Treasury, its complex internal protocols, and to verify all theoretical results. I'm going to launch a small local testnet with 5 nodes and show you the basic node API and how you can submit a proposal, issue a ballot, and all other stuff related to the Treasury operation. I've already had a compiled version of the source code, which is packaged in the executable jar. And also I've prepared several configuration files. Each configuration file contains settings of a particular full node. Among general settings, there are some related to the Treasury. Specifically, in the config file, we can set a role that will be played by a node. We can set it to be a voter, an expert, or a committee member. A voter and an expert are different roles. Only one of them can be chosen at the same time. And a committee member can be chosen only in pair with a voter or an expert. Having these options will signal into the node to do some actions related to a particular role. For example, if a user configured his node to be a committee member, then the node will automatically send all necessary transactions needed for protocol operation. For instance, registration, distributed key generation, joint decryption, etc. There is also an option for automatic ballot generation, but it is needed only for testing purposes. In reality, of course, all ballots should be submitted manually by a voter. Alright, so now I will launch a testnet of 5 nodes using a simple script. And we can see the 5 terminals with different login information printing constantly and showing how nodes are working. Currently, a Treasury epoch is configured to be 190 blocks, which will take approximately 1 hour. Of course, such short epoch is only for testing. In real life, an epoch probably will be a month or more, so there will be plenty of time to do everything. The Treasury epoch consists of the following main stages. It's a proposal submission, registration of voter, experts, and committee members, then randomness generation, then distributed key generation, then the voting stage that includes submission of voters and experts ballots, then decryption stage and tally, and finally Treasury funding of winning proposals, rewards distribution and penalties. Okay, so now our testnet is running. To operate a node, we can use web interface, which is implemented in Scorex using Swagger UI tools. It provides RESTful API for different functionality like sending a transaction, taking information about balance, etc. Now I will connect to the first node. I just need to know the port to which Swagger is binded. So from here we can do different requests to the node. We added a separate section Treasury, which provides different API calls related to Treasury. For example, here we can check the information about current status of the Treasury epoch. We can also check status of this node. Is it registered as a voter or expert or a committee member? For the current node, we see that it is a voter and a committee member. Alright, now our Treasury epoch is in the stage of proposal submission. So let's submit our first proposal. We need to use a special post request, and we need to provide an information about proposal in JSON format. There is already a template that can be modified with our information. Currently the submission is very simple. We need to specify only the proposal name, let it be development funding, and requested amount of tokens. The payment address will be automatically generated by the node and added to the proposal transaction. So we see a success response from the node. At this point the proposal transaction should be created and sent to all other nodes. We need to wait a bit until it will be included in the block, and then we will see our proposal among all submitted proposals. Okay, so seems like we got a block, and now we can see our proposal among all submitted proposals. After the registration phase is finished, there will be a randomized process of selection of the committee. Members of this committee do the 5 rounds of the distributed key generation protocol. This protocol is resistant to the failure of up to half of the committee members, including malicious behavior. So if the honest majority exists, a correct shared encryption key will be generated anyway. Okay, now the epoch reached the voting stage where we can submit our ballot. First of all, let's check current height of the blockchain. We can use our web interface for this. We see that we are at the block number 110, and indeed it is in the range of voting according to our schedule that is fixed in the code. So let's go to the ballot casting page and issue a ballot. Basically the interface is the same as for proposal submission, but the information is different. We need to provide information about our choices for all proposals. Each row in the request corresponds to a specific proposal. First we need to indicate proposal ID. In our case it is 0. Then we need to do our choice. We can choose yes, no, abstain, or the expert ID in case of delegation. Let us vote directly this time. Now our ballot is successfully created. Behind the scenes it was encrypted using Treasury shaded key and sent to the network. Soon it will be included in the blockchain. The ballot will remain encrypted in blockchain and nobody can tell the actual voters or expert choice. And since Tolly phase doesn't require decryption of any particular ballot, so there is no more actions to do for the voter, and we just need to wait until the voting and decryption stage will be finished, and then we will see the final results. Finally, the first epoch has been finished, and it means that the final Tolly was jointly decrypted by the committee members, preserving the privacy of each ballot. At this stage, anyone can be assured that all ballots were counted and that the Tolly was calculated correctly. First of all, let's check the voting results. We have a special API call for this. We had only one proposal in this epoch, which is called development funding. And we can see the result. We had 3 voters and 2 experts, but experts don't have their own voting power unless someone delegates them. For the current Treasury epoch, each voter deposited 10 coins, so it means that in total we had 30 coins voted. And indeed, we can see that our single proposal received 30 coins, voted yes for it. Since it's 100% of all voting power, this proposal should be funded. We can also request debugging information for our Treasury epoch and check all Coinbase rewards that were paid in this epoch. There are many items, and one of them is the payment for our proposal. Other items are rewards to voters, experts, and committee members. This is actually all that I wanted to show. Currently another epoch has been started and everything will be repeated. So you could see that From the user perspective, the involvement in the process is really minimalistic. In case of a voter, he should only configure his node and then only one time per epoch do ballot casting. In case of proposal submitter, he should only issue a proposal at a specific period of the epoch. For the committee member, there is no direct user involvement at all. Everything will be done automatically, except of course configuring a node. That's all. Thank you for watching the demo. Finally, I will add a couple of words about the integration of the Treasury into ZenCash. There are two major ways that can be taken: integration inside the core consensus protocol and integration in the sidechain. Actually, the Treasury model is agnostic to the choice because it can be implemented in both ways. Currently, the decision was made to take a second option and to implement it as a sidechain. And in my personal opinion, it's a better way to go, because introducing such big changes in the core is extremely risky. In case of the sidechain, there are also several options. One of the most obvious is to take the existing prototype implementation of the Treasury and modify it with necessary requirements. But it should be clear that this implementation is only a prototype. It was not supposed to go on production, so a lot of work should be done from the refactoring, testing and security audit side. And the Scorex framework itself currently is not production ready, unfortunately. Another option is to choose some other blockchain framework, for instance Hyperledger, and to use it as a sidechain. The Treasury probably should be implemented from scratch in this case. Currently, as I know, this question is under investigation. This is actually all I wanted to share today. Thank you for your attention.